I gotta get a new stand, poor little dude. Okay. So now. So if that was this plane, that is that plane, and this is the ceiling. So I got that plane, and that plane. Where do you think the answer is?
Where all
three planes meet. So where does that plane, and that plane meet? That upper corner there, right? That would be a point in three-dimensional space. So this is a point. Just like that's a point in 2D space, that's a point in 3D space. It'd be like going 2, 5, 3. Alright, so how much do we have to understand the geometry right now? Not the most, because we're going to focus a lot on algebra, but at least wanted to start off with, this does have a geometrical interpretation, what we're doing, always.
So if you
Pretty much always.
If this was on the test, how would you show it? You would give us like those 3 pages?
Yeah, good. I would never, I'm just showing you how I put, I wanted a system of equations that would work. So I decided to let you help me, right? Instead of trying to do it all in my own head. So I started with the answer we created. Are you ever going to have to do that on your own? No. So I'm about to get into what you're going to have to be able to do. So everything I've talked about so far has been explaining ways to look at what we're about to do. I love it. I could just hear it now, somebody saying, yeah, that teacher, he takes forever to get to the part that really matters. Oh, man. Okay. So now we got to figure out, how the hell do I solve this shit? Right? The problem is, what's the immediate problem? I mean, why is that harder? There's 3 things I don't know, right? If there were only 2 things I don't know, like that would be easy. I could do substitute, I could do elimination, right? I really want that to make sense, because that's the whole thing that motivates what we do. If only I had 2 equations with 2 variables, I know what to do. I got 3 things with 3 things I don't know. Shit. So that's why it makes sense. The first thing I do is I pick a letter and I kill it twice. Because I'll be left with an equation that has 2 variables that I know what to do with it. Alright, maybe. Some of you guys might realize, if you look at this, the side that says section 9.1 as an example. I'll let you look at that later. Alright? So we're basically going to do those steps right now. So this is equation 1, this is equation 2, this is equation 3. Pick a letter for me. What's the easiest letter to kill up there? Twice.
Y.
I don't care. Y is pretty nice because these are both 1y, but x is pretty nice because that's negative already. So let's do x. Let's kill x. I like it. So, help me out. Somebody help me out. What's one way, using any pair of these, that I can kill x?
Negative 2x, the number 1.
Yes, if I multiply number 1, the first equation by negative 2, won't that kill those? So here's what I mean. Take the first equation and multiply it by negative 2. What do you get when I do that? Good, negative 20. Some people, the biggest mistake is they forget to do both sides. You can't change just one side of an equation.
Why did you multiply by negative 2 again?
Because now if I take number 2, leave him alone, what happens when I add them together? The x's die. Yes, ma'am.
One question I never got to ask last semester when we were doing this is that why is it okay to multiply one but not the other? I mean, I understand that we're trying to find the answer, but how do we get to,
But we've done that before, so I don't know. You also have that question with the other problem I had up here. Like if I had this, I'm not even trying to make it work. I can multiply this by 3. I mean, it's the same exact question as this. Why, when I'm adding these together, why am I allowed to multiply this by 3 and not change this one? I really want it to make sense. Now that's kind of a silly question, right? Why would you want to change this one? This is the only one that needs to change. So what do I do to change this one? multiply both sides by 3. Now I said it a different way, the top side and the bottom side. But now, so by multiplying both sides of this by -2, have I changed the equation? No. I've made it look different for a minute. And why does this new look better? Because those go away.
And the main thing is that the X, Y, and Z don't change.
Yeah, the values that they would be don't change. Only the coefficients change.
Could you, instead of canceling X out, could you cancel Y out?
Totally. You pick which letter. Some people said Y. I just,
So you could do
I'm the
negative-
teacher. I want to kill X.
You could do -1 to get a Y out.
Yeah, you can multiply this by -1 and you can kill these. And then multiply this by -2 and then kill these. I like it. Totally. Or you can kill the Z's. Z looks good. 3 times this plus this, 5 times this plus this. Right? It doesn't matter which letter you kill, just do it twice. Now we're just not done. Let's do this and then you'll see why I keep saying you want to kill the letter twice. So we've just killed X once. What's this? Now I would immediately, what do you think I would do with this equation immediately just to make it look a little better? Oh, you guys can see it. Yeah, I can just multiply both sides by negative. This is equation number what? This is a brand new equation we just made, but it still works with all these. It's equation number 4. That's crazy, because we already have 3.
Now put the 3.
So now I can say this is y plus 5z equals 20. So that's equation number 4. Right, just multiply both sides by negative to kill all the negatives, just to make it look better. How are we doing? So all I did was something that feels very familiar. I said if I multiply by -2, these will cancel. So I did it. This equation, while still gross, is nowhere near as gross as any of these. Because in this equation I have only 2 things I don't know. Over there I got 3 things I don't know. Okay, maybe. Stay with me now. Alright. Now I can't use 1 and 2 again. How else can I kill X? Well, I have to use, well, I'm going to use 1 and 3. And this time, what am I going to multiply 1 by? Positive 3, because they're already different signs. Yes, who had a question? Oh, okay, sorry. So if I take the first equation and multiply by 3, what's that?
3x plus 3y plus 30.
Good. And then leave the third equation alone. What do you get?
5y
5y
minus 2z
minus 2z
equals
19. So there's equation number.
5.
No way. All right, now that I'm only boxing them off. I'm not saying I'm done, but just so I can find them easily.
Maybe 4 and 5.
I don't know. What? I'm sorry.
The equation 4.
Yeah, now I'm going to look between 4 and 5. Now that looks more like from before. There's only 2 unknowns, 2 equations. So I really want this to make sense. This kind of problem is a little long, but it is not difficult.
Different row steps.
You just got to remember that. But the motivation makes sense, right? It's not really memorization. It's like there's too many letters. All right, kill one of them. Twice. Right? Just because it feels so good that first time. Sorry, that's a little dark. It's a little dexterish. Yes?
The second time you cancel it, do you have to use the third equation?
No, but I wouldn't want to use the second. And I can't use 1 and 2 again. Because then I'll just get this.
Right. Okay.
So I have to use 1 and 3 or 2 and 3, and 1 is the good one because it's got a coefficient of 1. I like it. Good question, and the answer applies all the time. Yes?
What you're doing right now is canceling every x right now.
Yes, totally. And again, just to reiterate somebody's question earlier, I could have done everything we just did. I could have canceled y twice instead, and then I would have had 2 equations with x and z. All right. All right. Some of you guys are already like, is it time to freaking go now? No, nowhere near. Sorry. Too bad. So what you just said, somebody out there just said this. I take equation number 4. Let me write them again over here. y plus 5z equals 20. And equation 5y minus 2z equals 19. Now what can I do? Yes, ma'am.
Okay, so we're canceling and killing all the x's. What are we solving for right now?
Now we're gonna
The goal from the beginning is to figure out what x, y, and z are.
Okay.
Just solve for all three.
Exactly. So I know I'm going to be done when I know x equals something, y equals something, z equals something. Then I know I'm done.
So once we get this third equation, then we're solving for
See now, so if I kill one letter twice, now I've got less unknowns to deal with. Now I know how to, now if I kill a letter again, I know the other letter. We know how to do this. So what method do you want to use? We can use a different method just to show you. Solve this for y, and then I can use the substitution method, right? But you can always use elimination if you like it. But here, if I subtract 5z, I get the fourth equation becomes that, and then I can plug this in there. Substitution method, right? If you want to. You could multiply this by -5 so that these will die. Doesn't matter. I'm being more subversive in saying let's replace y. It's like an invasion of the body snatchers approach, right? I watch way too many horror movies. So how does 5 look now? 5 times...
Wait, what way?
What's up?
Now he's on substitution.
So again, just to remind you, you can use any method you want to once you've got this. What methods do we know? Graphical? No, thank you. I don't want to graph these. Elimination? Sure, I can do elimination. Substitution? Sure, I can do substitution. Why is this a good candidate for substitution? Because I can solve for y easily. I don't make any fractions. Some of you guys take this and solve for z. Why is that a little crazy? If I solve for z, I'm going to make fractions, which if I forced you to, you should be able to do. But if I have a choice, I know math really well. I'm going to choose the path that has no fractions if I can, because that's just one place where humans make mistakes. I don't care how much you know. There. So what am I doing right now? We know these are true. These are true. We know these are true.
Can you do the same methods that you did over there?
Yes, I can. So I could graph these two and see where they meet. I don't want to do that. I could use elimination.
Yeah.
Sure. Or I just wanted to show you substitution would also work. It doesn't really matter. Right? Yeah. So again, like always, there's more than one way to do any problem. I love it. So you could use, but just to show you, it would still work. What do I put here now? 20 minus 5z.
100 minus 25z.
Yeah, so I get 100 minus 25z. Minus 2z is minus 27z. Let me stop there for a second. And now just solve for z. Right? Subtract 100.
What did you times by -1
What do you mean? And then divide by -27?
It's 3.
It's 3. So z is 3. Why are we happy with that? Because
Z is 3.
we knew it was 3. We knew from the beginning what the answer was. I like it. I always want some student to go, well, if you know from the beginning what the answer is, what do we... Because you're not going to know from the beginning what the answers are in the book. I like it.
That's just part of it.
Yes, good. I like it. I just want to make sure everybody's with me. We got one answer. Now it's like dominoes. Yes. Not the pizza.
Is there a shortcut for us to plug the z into all the z's and just solve for
Well, it's not really a shortcut. You don't want to plug it in here. Why do you not want to plug z in here? Because then I have how many other unknowns in these equations? 2. I'd rather use one of these equations. Because if I plug 3 in here, I can solve for y. Right? So this is what I mean by dominoes. Once you know one letter, you fall back one level, and now you can figure out another letter. Now you know 2 letters. You can fall back one more, pick any of these. I'd probably pick the first one. And plug those values in. You guys see that? So we know z is 3. So now plug a 3 in there for number 4.
Y is 5.
In fact, right here is even better. Y equals 20 minus 15. So y is 5. Thank God. Right?
So you plug into any
Part of my brain was like, oh shit, if we don't get those numbers, I'm going to really...
So you can plug into any problem that you solve.
Totally. Well, either one of these.
Yeah.
Any of these wouldn't really do any good. But now I can use these. Why can I use these now? Because now I know two values. So if I plug in y and z, I can solve for x. So that's 8. Subtract 8, you get x is 2. Bam. But now you see why I gave you that handout, because this is not the easiest thing to follow. I understand. The one big trouble that a lot of students have is organization. You get lost in the middle of a problem, like you do if you try to look up here right now. You had to follow me as I did it. So I tried to make a handout that was very, very, very step by step. Once you see the steps, they almost never change. Yes?
The only thing, how did you get the y plus 5z equals 20?
Oh, are you cool with this one?
Yeah, I'm cool with that one.
And then you just divide by -1. If everything's negative, make everything positive. You just multiply both sides by negative or divide everything by negative. Yeah.
Why don't you want it negative?
Just because it's generally better not to.
Okay.
I mean, do you agree that that looks better than that? I don't know if you agree with
Yeah.
that. Okay, good. It should on some level look better. Yeah.
So when you got Z, you're just, and when you plugged it back in, you're just checking it to make sure it's actually 3.
No. I plug it in here to figure out what y is. And then I plug those in here to figure out what x is.
Okay.
So I use the one with 2 unknowns when I figure out one of them, because then I can figure out the other one. And then I use the one with 3 unknowns when I know 2 of them, because then I can figure out the other one. I'm not flicking you guys off by the way.
And when you do all that work, do you normally have the 2, 5, and 3 already as answers? Because you're getting the same 3 numbers again.
Because you're taking.
Because we created this using these, right? But of course in the book, they're not going to tell you that.
Have that.
Yeah. I like it, maybe.
And then when we plug those numbers in, they should all equal their.
Exactly. So to check it, to really check this, you would use the other 2 of both of them. I used this one to get my supposed answers. Then I plug 2, 5, 3, 2, 5, 3. It has to work in both of those. Because it could work in one and not the other one. Because how many answers does each of these have? Infinite number. So you could have found an answer that works in 2 of them and not the third one. And there's a lot of ways this could have no solution. Couldn't I have 2 planes that never meet? Or I could have 3. Let me see if you guys. I could have 3 planes. This one hits that plane, and then this one hits, and they never triangulate. They never hit one single point. So you have like 0 equals 1 somewhere, and it's trying to tell you, dude, some of your planes just don't agree with the other planes. It's too bad for you. So in 3 dimensions, there's a lot more ways to have no answer. Because they have to line up perfectly and have one single point. They don't have to. Just like lines don't have to meet at one point. They can be nowhere or everywhere. Planes have a lot more kind of flexibility and options. Right. Maybe. Here, let me give you guys one to try on your own. Okay. By the way, if several of the problems in the book look something like this. This is kind of silly. Would you do all the shit I just did?
No.
Hell no. Why? Because one of the... Do you see how there's less unknowns total? So then there should be a quicker way. So the minute that any of the letters are already missing, then there's a shortcut. There's a quicker way to get it. Do you guys understand? So this one's real. You just plug in there, you figure out why, and then plug them in there and figure out what X is. And then you're done. So if there's any empty spots, there should be a way to do it quicker than the complete way. So I want to show you the complete way. So let's get one that's the complete problem. Here we go.
I like the other one better.
I figured if you didn't, I would look at you all like weird. Okay, let's try this one here. Negative, right? Oh, these problems suck so bad. You forget a negative or you add something incorrectly, the whole thing goes to shit. So how do I grade these? I grade these on, are you showing me that you know the process to use? Because I completely understand that there are many ways to make some stupid little mistake. So don't just erase everything if you do that. Leave it there. It's proof that you know what to do. And then I can find a little mistake and decide if I want to take a point off or not. You're trying to show me you understand what to do. Because I've done these in a class where we had 11 variables. So that meant I had how many equations? 11 equations. I'm not going to do this to you. Don't worry. I won't pay it forward. And just to make sure nobody does this, don't ever kill a letter and then kill a different letter. You understand how that's not going to help? You need two equations with the same two unknowns. So kill a letter twice, that same letter. All right, get angry at one of the letters.
Oh, yeah, you did. Turn it out.
Like, it's a little bit 12 anyway. It should come out to be nice whole numbers, or integers. So if you're getting fractions, something went horribly wrong. try to catch up to you guys. What variable did you kill?
Why?
I like it. So we got them all covered. They're all dead somewhere in this room. So those that killed Z and Y, the same exact reasoning, because the Y's and the Z's are almost the same. You see that? One of them has a 3 in front of one, and then one's negative, one's positive. Beautiful. X's, the X people are nifty people because they realize multiply both of these by negative, and then that would kill both of those, right? So I don't know which way to do it. Let's see. Let's do it Y. Let's kill Y, because we killed X first. We'll kill Y. We'll work through the alphabet. So what's the most immediate way to kill Y? Yeah, if I take 1 and add 3 to it, I get the fourth equation. That's just a coincidence. So what I get when I add 1 and 3, I get 2x. Good, plus 2z equals 8. That's crazy. And what would I do to that immediately? I would make that become x plus, yeah?
4
Equals 4. I like it. So that's equation number 4. Much better than any of these. So if you solved if you killed Y, you should have gotten one of these. You should have gotten this.
Because I took the first one and I multiplied it times 3 to get rid of Y into 1 and 2. But
Sure, yeah. You ready?
0 times 3 is still 0.
I'm sorry, where? Sorry?
So I get the first one, I can multiply the first.
Yeah, good. That's what I would have to do next.
Times
Because
3.
how else can we kill Y? I can multiply the first one by 3. So 3 times the first one. So what do I get there?
I get 3x plus 3y minus 3z 0.
And then add that to the second one, right? Because then that would cancel with these. I really want you guys with me here. How can I kill? If only there was a 3 there. Okay, there's a 3 there now. Now if I add these, that'll die. So if I add it to the second one, I'm still not sure what's equivalent. So what do you get here? 4x. The y's go away. Minus 2z equals negative 2. Is that cool?
Yeah, that part's fine. It was the second part that I got to do. I got the fraction.
And then I would divide by 2.
Yeah, you got fraction.
So this is the fifth equation. I would divide this by 2 and get 2x minus z equals negative 1. There's my fifth equation. So let me put those up here. And again, if you chose to kill a different variable, hang on for a minute. We'll see if we end up at the same answer. Right? No matter what variable you kill first, you got to end up at the same answer. So my fourth equation is this. My fifth equation is this. These kick ass. Those kick so much ass. Why?
The z's would go away.
The z's want to die. Here I are, z's. You asked for it. Right, so then when I add these together, I see a lot of quizzical looks out there. You guys with what's going on. If you're not, you gotta speak up. Several of you have the same look on your face.
If I divide by 2 there.
Because I can. Anytime I can make the numbers I'm working with smaller, I will. Right? Do you have to? No. But it's a really good idea. Because then your numbers are smaller.
If you didn't divide by 2, you will end up with the same answer.
Totally, of course. Because it's the same equation. That equation is the same as that one. Which one looks better? That one. Yeah. If you don't see that you can divide, who cares? Like you just said, you're going to end up in the same place, right? So if you had this, if you left this as it is and this as it is, you would multiply this by 2 and then kill the z's. We'll be at the same place.
So it doesn't matter which of the 3 we take initially.
I like
You
it.
just want to take the easier ones. Is that right?
Yeah, whatever immediately makes sense to you as to how. So your first thing in this problem is, who do you kill twice? So if x had like 5, 6, and 11 on it, I ain't touching the x's because they would be difficult to make them the same. So yeah, you look for which one looks to be relatively the easiest letter to kill a couple times. Here, it almost didn't matter. They're all equally easy. or equally hard, however you want to look at it, they're all equal. So kill a letter, any letter you want, kill it twice, because now you have two equations with the same two variables. So when I add these, what do I get?
3x.
Cool. So x is 1? I don't know. So then you can plug it in here. So z must be 3. You can see if I plug a 1 in, 1 plus 1 is 4. 3. And now I know x and z, I can plug them in here and figure out what y is. So x is 1, z is 3. So this is y minus 2 equals 0, so y equals 2. Alright, so let me try again. My quizzically faced people, can you formulate a question for me? What's happening? I know you might have picked a different letter, but the exact same process applies.
And I solved for z, but I got x equals minus 6.
Let's say I got 6.
For which one?
I solved
For
z.
x?
At first.
Yeah, I got rid of z, and then I solved for x.